All right, I'm ready. I'll kick it off.
Thank you.
Okay. Good afternoon, everybody. Welcome to today's final installment of our three-part series, episode 3. And before I pass it over to our presenters, I just want to review a few things. All lines have been muted. And if you do have any questions, please use the chat and we will get to that at the end. Our presenters today are Adam Sowers and Dave Arnott, Consultant Relations Managers, part of our solutions group. And with that, I'm going to hand it over to Adam.
Very good. Thank you, Gina, as always. So as Gina said, I'm Adam Sowers, Consultant Relations Manager for the Western region. And with that, I'll kick it over to Dave. Dave, why don't you introduce yourself?
Sure. Thanks, Adam. Welcome, everyone. Yes, Dave Arnott, Consultant Manager for the East. Happy that you guys could join us for our final episode, but certainly we'll recap everything that we've talked about up to this point as well. So back to you, Adam.
Awesome. So agenda for today, guys, we're going to keep it pretty short and sweet. Shouldn't be more than 30 minutes. We're going to do a quick UN series Gen 2 overview, just so everybody kind of has a equal playing field or starting point. We are going to do a live demo and kind of review the past settings of how we got to where we're at today. And then we're going to go into NEC SpectraView. We'll go into NEC self-calibration. We've got a summary slide of kind of all 3 episodes that we've done to date. And then we'll open it up for Q&A, or as Gina said, if you've got questions as we go, please use that chat function and we'll either stop and answer those questions as we're doing the presentation, or if we get too many, or if we get into a flow, we'll answer those at the end. So with that, Dave, I'll kick it back over to you for the overview. You're muted, buddy.
No, yeah, thanks, bud. All right, thanks, Adam. So just to go over what we're talking about as far as the NEC video wall portfolio, we have 8 total displays in the lineup, and they really, if you look at the top line, 8 displays, they're all 24/7. They all support landscape and portrait orientation. Then we go down to the next level. So it's 46-inch, a 49-inch, and then we have 4 models and a 55-inch. So starting at the left, the differences that we've highlighted in red. So we've got different bezel sizes and we have different brightness levels. And that's what encompasses the 8 total displays. So on the 46, we have 2 units, a 500 nit panel and a 700 nit panel. Both of those are at 3.5 millimeter bezel. That's the total gap in between, or total inactive area in between 2 displays. And the 49-inch, that goes down to a total of 1.8 millimeters, and that's 0.9 on each panel. So combined, you get 1.8 of inactive area on that. And there actually is no bezel. Actually, it's just the frame of the LCD, so it's a clean finish, and we'll show you that in a later slide. The 55-inch come in the 2 varieties of 500 nits and 700 nits, but they also come in 2 bezel sizes. So the 55's 3.5 is kind of the entry level 55, and that's in a 700 nits, and also the value series in the 500 nits. On the higher end, the 55-inch UN 55S and VS models are 500 and 700 nits, but they have a 0.88 total gap. So that's 0.44 millimeters. So very, very small. And I've kind of put those 4 pictures on that slide to sort of kind of give you an idea of the bezel and its impact on a 2x2 in there. So we try to represent that on that slide. If you just look at some of the Generation 2 upgrades that we went through. So our original was a 551. This is the 552 series. So we talked a lot about the SpectraView engine, and we're going to really spend some time on that today. So I won't cover too much there. But the connectivity is different. So we're having HDMI loop out as well as DisplayPort, so that it gives us some more flexibility and better support on HDCP. So we're doing DisplayPort and HDMI looping. We're supporting HDCP. And then one of the things that we think is super important on any video wall or any display that we sell on our higher end is a high haze front surface. And what that means is it means it's very low reflective, at a very low reflective value, so that in high ambient light conditions or where light can't be controlled, we're going to diffuse that light and be able to make sure we can give you a picture that your audience can read and see from all angles. And then a full control through IR, RS-232, and LAN. So what that means is through the daisy chaining, which is separate from the signal path of the HDMI and DisplayPort, you're able to control all monitors together or individually, separately, through the remote, through RS-232, or through LAN. So really, it's a very, very robust control feature in there. And then, you know, the things like auto ID and IP we went over, but full metal chassis. So these are rugged displays, commercial displays. They're not going to, over time, give way. They're mounted to that mount. They're designed not to move. They are UHD loop capable, so that's part of the daisy chain tile matrix feature. And then we do also support the OPS slot, so that can house some of our single board computers, as well as optional inputs like HD base T and SDI, as well as Crestron, the NVX D80 module that was designed. So just wanted to give you some just kind of a background update that we went over in the first couple of episodes. So in here, I'm going to transfer it over to Adam to kind of give us a synopsis of the live demo that we've done.
Yeah, thanks, Dave. So just kind of a level set of where we've gotten and how we've gotten to episode 3 at this point. So just some things to keep in mind. You can actually pin my video so that you can see the largest picture possible when I go over to the other camera view. In those previous episodes, we've set these displays at 300 nits and at 7,500 Kelvin. And you'll really see, especially anybody that's used to broadcast type applications, you'll see why those numbers become so important and why, as NEC, we give you that flexibility to do that. The other large part of what you're going to see, I've actually got a 1 wide, 2 high video wall that I'll show, but we actually have it set up as a 2x2 video wall. And I'll show you some of those reasons why and what we're doing as we kick over here to the other video. So as we do that, let me switch. And with the magic of TV, here we are. So as you can see, and I'm going to let this content kind of play through, we've got a 1 wide, 2 high video wall. These are 46-inch panels. We virtually set this up through Tile Matrix to be 2x2. So what Tile Matrix thinks it has is display number 1, or the top display, is position 1, and display number 2 is position 3. So it actually thinks there's 2 other displays to the right-hand side of my wall. And where this really becomes important is with a feature we've covered called tile cut. So the content that you're currently seeing is standard 16:9 aspect ratio content. And as we all know, or if we don't know, what typically would happen with this is you would only see a portion of this content. But what we're able to do with tile cut, and I'll just show it here briefly. I'm actually going to take tile cut off of display 1 and turn it off. And you can see automatically what it's done to that top piece of content. It's shifted it back over. So really the importance of this, or where this comes into play, is that content creation. We don't always have to have custom content created, especially if we're in an out of aspect ratio video wall, which we are here. It gives you that flexibility to use standard content. And again, what we keep saying is more tools in your toolbox. So this is a great tool to be able to have within that. Some of the other things that we covered, and Dave actually mentioned, is the ability to control the displays not only as one unified wall, but I can actually talk to each display independently, like what I just did now, in turning monitor number 1, turning tile matrix, or not tile matrix, sorry, tile cut off. I could do that same thing and talk to the entire wall. It doesn't matter if it's 1 panel or if it's 100 panels, it's all going to communicate as one unified piece of canvas, so to speak. The limitations that we talked about last time, and I really want to make sure we cover these again, is with this series, UHD 60, we can support up to a 4x4 video wall and take in that UHD 60 with no problem. If it's a larger wall, UHD 30, we can do up to a 10x10 video wall. And with that, Dave, I think I've covered everything. If you can kick back to the slide deck. Switch my camera.
Should be,
Yep.
should be back up.
I've got you. Perfect.
Perfect. Thanks, Adam. So on this episode, with the kind of the new content, we're going to go a little bit deeper into the SpectraView engine. And I think on my invitation, right, this is really what's separating NEC in the LCD video wall game. The ability of what has been developed of the SpectraView engine. This technology has been built up from our graphic desktop displays where it first originated. I think it was back in 2010 or somewhere in there. And really for those users that demanded the best color performance in a desktop monitor for those graphic artists and those types, it really became important, right? Color. And then when you get into video walls, obviously color and uniformity, it couldn't be any more important, because that's at the end of the day, after all this things that we're talking about, it's what the end user and their customers are going to see on that screen. They will remember if all those monitors don't match. That's the one thing they will notice. So I think if anything we take away from today is the ability. It's really the ability that we have in the technology that's in each display to be able to kind of get to where you need to go. You know, I don't think anyone's going to remember all the steps that we talk about in the next few slides, but it's just knowing the ability that we have that ability to get there. Kind of gives you a peace of mind when using the NEC. So in episode 1, we talked about out-of-box uniformity. And what we were talking about is that from the second that we remove it from the box, that it's actually going to be, hey, Adam, I made a mistake. Are these your slides?
No, you're good, brother.
Okay, all of a sudden I'm thinking, wait a minute, I think we switched it up, but that's okay. So anyway, so basically the goal here of the SpectraView engine is it gives the ability to have matching displays out of the box. So what this technology does is it gives us five points of reference, right? So that's color gamut, uniformity, luminance, gamma, and white point. All this is actually, as the units come off the factory line, they are then calibrated with a sensor. Each one individually is then set to its specific settings. So you can see down here the presets at 10,000 degree Kelvin white point. The 700 nit panels products are shipped at 500 nits, but that's when they say they're 500 nits, they're 500 nits exactly. And then the 500 unit products are set at 350 out of the box with a massive 500. But you know that when you set it to 500, it is 500 nits, and when you set it to 350, it's 350 nits. So you can sort of see when we look at this SpectraView engine and sort of what it's processing. It's kind of a constant feedback loop that basically is taking all of this input from some of the OSD settings, input detection, its basic color lookup tables, and all that information. And then it's kind of looking at it, and then it's taking information from the internal sensors, which would be like the backlight sensors and temperature sensor, right? So as it ages and it senses temperature, it's making calculated decisions of best how to correct color as it ages, or the brightness of the LCDs to basically correct that uniformity across the wall. So that's sort of kind of what's behind the out-of-box uniformity in the SpectraView engine.
And Dave, before you go on, just one of the real-world applications that we've talked about previously, and if I get any of the details wrong, you can absolutely correct me, but Infocom last year, we had over, I believe, 100 of these panels that we had at Infocom, and anybody that's been to Infocom knows that that's kind of the ultimate trade show for manufacturers, especially such as NEC. So we want things to be perfect. And we were able to take all 100 of those displays out of the box, put them into use without any single calibration. So just a real world application of how much we stand behind this technology that Dave just explained.
All right, and I'll give you the next slide. Hold on. There you go.
It's starting to come. So as Dave talked about, the SpectraView engine, it's pretty straightforward for the most part. There's not a whole lot of complicated steps as you see those screenshots of how to turn SpectraView on. And then some of those capabilities that we talked about earlier, even with the live demo, of being able to go in and independently set the luminance and the color gamma and the white points, things of that nature that most other displays don't give you that capability. So that's really what we're talking about today. Next slide, Dave. And then for me, this is really one that stands out again, is the luminance stabilization. So if anybody's familiar with like our projector lines where we talk about a constant brightness mode, this is very similar to what we do with our projectors in constant brightness mode, but we're talking about it in an LCD product. So think of this, if you take a 700 nit panel and you don't need all 700 nits. Let's say you could get away with, and I'll just pick on 500 nits. You can actually bat down that backlight to 500 nits. And by doing that, it's going to expand your overall lifetime of that backlight, because again, we're not using it at full capacity. So when you think about that, of typically run hours somewhere in the case of 50,000 hours, if you're using it at full maximum brightness, we can now start to tag more hours onto the end of that and still give you the capability of remaining that luminance over a great period of time, where it's going to be constant. There's not going to be dips or dives within that luminance chart, as you see on the right hand side. Next slide. I think here's where I give it back to you, Dave.
Okay. Sorry about that. I got all flustered in my head thinking I was talking about your slide. I couldn't even speak.
You got all excited, and I like it.
I'm like, I'm doing this wrong. I didn't pay. I have my notes right here. So another important feature is called uniformity settings. So think of a whole wall as being uniform from display to display. What we're actually talking about in this slide is uniformity within each screen. So if you look at these 4 charts with uniformity off, and if you look at that chart and think of that as the display laying flat on its back pointing up, and that area in the center, that's the high peak, is the center of the display, and as you go to the left and right and forward and backwards, that is the edges of the display. When uniformity is off on a display, that is a representation of the peak high nit level at the center and how it rolls off to the edge. And so when you look at SpectraView, which in this case, if we set it at level 1, you can see what it does is it sort of sets that uniformity. So it kind of drops that peak in the center to level off from the edge to edge. And what's important is this is not just only in our video wall product, but this is also our C and V large monitors. And then as we go on, our new MA series will have the capability too. So again, not all displays are created equal, and this is a great example of that. And then as you can see, when you get into this 5 levels, we're looking at level 3 up to 5 here. And as you look at level 3, you're starting to flatten that more. The one thing you are doing is you're limiting your total brightness, but you are flattening. So again, when you get into broadcast applications where brightness is not the most important thing, but uniformity could be, this is a feature that could be used there. And you can see that note that I just popped up there. At level 1, a color sensor is able to detect the variance, but it's very hard for the human eye to detect that difference in brightness from center to edge at level 1. So again, it's just showing the ability to correct uniformity within each display, and then from there, each display within the wall. So it's just that extra level of uniformity, brightness uniformity setting.
Hey, Dave.
Yeah.
Just throwing another piece into that, for those that don't quite understand what those charts are, because they can be confusing even to me the first time I saw them. You want to think of that as you standing at the top of that chart looking down if you were looking at the display laying on its back. Hopefully that helps explain that of what you're looking at. But the plane would be if that display was on its back and you were at the top of that chart looking straight down.
Perfect. Right. So there's the goal to give the customer the best possible image. Right. I hope I got that across. All right. So moving on to another function within the video wall. So it's the copy function. So when we're dealing with individual monitors, it becomes I now have to set up one monitor, get all my settings, remember all my settings, go to my next display, and remember exactly what I set as far as inputs and loop throughs and am I on HD 30 or 60 loop through, the schedulers, the OSD, protection modes, and power. All that can be quite daunting, even for a 2x2. Never mind 3x15 or 5x20, right? So what we've come up with is what they've added is a copy function, so that you can set all of your settings in the first display and then do a copy all. So you have an ability to check each box of all the settings that you want to copy, and then that'll follow the daisy chain right down. So that's a great time saver, especially if a monitor had to be replaced somewhere along the line. We can just copy settings to the new monitor. You know, that's sort of part of the install, but again, if we can make it easy and quicker to install, you know, I think that's best for everyone. And moving into self-calibration, so this is something that's brand new. So what we did say at the beginning is that each monitor is calibrated at the factory. Each one individually is put on a sensor and run through the paces to actually set it to its correct parameters. What self-calibration allows us to do is to plug the sensor, right? When we take, I actually have to have one here on my desk just for a better view, but our color sensor that we're shipping with our kits, and we also have a line item to be purchased with any of our custom solutions. But we can plug that directly into the USB port on the monitor. And what they do is you do a self-calibration, and basically all that's doing is calibrating the monitor to the sensor, so that now that the monitor knows what its settings are, now it wants to see what the parameters that the sensor feels it brings in, and then that way they're on the same page. So they have a baseline of what the sensor is seeing to what the monitor settings are. And I think that'll become a little bit evident as I move on to the next slide. So really, again, it's just really this goal here is to sync up the luminance and color settings to the sensor at that point. So white copy. What does white copy mean? White copy basically is a great function if we ever needed to replace a screen that's in a wall that's down the road 1 year, 2 year, 5 years, somewhere down the road. We want to be able to do what's called a white copy, and what that basically means is that we're going to be able to take that sensor and copy the white data, which would include color, temperature, and brightness, and be able to copy it onto the new monitor to set it exactly like the adjacent monitor in the video wall. So that's basically what white copy would do for us there. And I have a great slide to go to here, what I think will probably be more visually easy to explain. So self-calibration on new display. We just talked about that, so that would be step one. Step two is to set a white image on adjacent display. Step three is to place now the sensor on the adjacent display. Remember, this is the older monitor, so we want to run now the white copy on the older monitor to get the white value, right, the color, temperature, and the brightness settings from the old monitor. Then at that point, once it has the data is then connected to the new monitor. We exit out, and at that point, the new monitor should now align and have its settings calibrated to the older display. Adam, does that make sense to you? Is there anything you want to add to that?
No, it's perfect. I just want to make sure we're driving home the importance of this. We've got a few end users that are on the call, so I want to make sure they understand really where this comes into play. Older technology and even some competitive products, if you have to replace a display, and I'll pick on the 3x3 that Dave is showing, let's say you had to replace that center display. Without these functions and without this capability, there's no way for you to be able to get this back into alignment. So that center display is going to have a different color point as well as a different luminance point, and it's going to stick out like a sore thumb. So imagine, to Dave's point, it's 5 years down the road, center display dies for whatever reason, you have to go in and replace it. This really assures the investment that you've made into this video wall, that you can have long life from that product, even if there is a damaged panel or a panel that has a warranty issue for whatever reason. We're giving you those tools to make sure that your investment is long term.
Excellent. All right. So moving on to the calibrator. So we're going back to the sensor in our NEC display wall calibrator software kit. So we've done a couple of things here. We've speeded up the time in which it takes its overall. So basically, calibration can happen a lot faster through the new improved chipset. But we've also added what they call corner uniformity correction. So this is unheard of. This is now calibrating within one display. We can actually now calibrate each corner. So if you take a step back, inherently in the technology, so this is not an NEC thing, this is an LCD technology. Inherently in every manufacturer, there's always going to be some types of color shift within the display. We try to compensate for that as much as possible. But what this is this ability to now, when on site, you actually have the ability to now look at each individual monitor, and if it becomes that critical, you have the ability to actually tweak the color on each display within different sections. And then this one here, we're showing a large 4-quadrant there, and you can see how simple the software is to use. You look at that corner that you're looking at. You ask yourself, is it too red, too magenta, too blue? You say it's too blue. You click too blue. It makes a minor adjustment. You then reevaluate. If you think it's still too blue, you click it again. So it's a very small step by step. But the point is here is we have that possible color uniformity enhancement. So I think that's really a cool thing. And then the update on the uniformity correction, right? That goes into what we see down here in the bottom right, where we can go through a 9-point or a 15-point calibration to do uniformity correction. So that's another step that's been built into the video wall calibrator software. So kind of looking here more of a visually here going through, and this would be more of a 15-point. And one thing to note, I don't know if you can read on the text, but it actually tells you how many points it's going to measure and how long it'll take you. So in this example here, it would actually give you the ability to do the 3.7 minutes would take per monitor. I think I saw a question pop up. Do you have that from Richard?
No, he must have sent it to you privately. I don't see it.
Yeah, I think his question, I saw it. I think it was something, and I have to go find it, Richard. I apologize. Why wouldn't you let us just plug in the numeric RGB value? And we absolutely can within the software through the on the right hand side of that computer image is the setup of the calibration edit. So you can edit white point by CIE, by Kelvin, you have gamma curve, you have all the ability, and I can send you a slide on that, but we give you all that ability within the calibration display software to actually go down to that level. So, I mean, that was just kind of going through a couple of the highlights of SpectraView Engine. There's so many things that we could go through. But I think if we kind of step back, and I'll let you start off on this, but just kind of summarize our 3 weeks of webinars here.
Yeah, so really, I guess the thing that I want to make sure we point out is if you've missed episode 1 and episode 2 and you're kind of somewhat going, wow, I'm not really sure where to even start, those episodes are recorded and you absolutely can go back and view them. Or any of the solutions team that Dave and I are part of would be happy to have, offline conversations or deep dive conversations into particular products or projects that you're working on. So with that, just keep that in mind. It's not that we expect you to remember everything that we've gone through in the last 30 minutes, or even if you've watched all 3 episodes, this is a ton of data for you to take in. But just kind of an overview of all 3 episodes. Just keep in mind that we've got 46, 49, and 55-inch products. We've got them both in the 500 and 700 nit version. We've increased our HDCP capacity, but even with that said, there's ways that we can work around HDCP to be very value engineering, if you will. And another way to say that is there's many ways that we can look at different solutions. So it may be utilizing just tile matrix. It may be utilizing tile matrix with another product like a video wall processor, or we can even go to the extreme of a full video wall processor to where each display element is being fed independently. High haze panels, that's a huge part of this and really important for everybody to keep in mind of why we have those high haze panels in our products. The ability to control not only through our IR or RS-232, but TCP/IP, and the ability to do that not only through third-party control systems, but even simply just the IR remote. We've got a lot of control just through this simple IR remote and the human sensor that we've utilized in the documentation, or actually the wall that I have behind me. Tile cut, we talked about that. The ability to do UHD 30 and UHD 60 that we talked about earlier. That out-of-box calibration. Keep in mind my example of Infocom and those 100 displays that we were able to put completely out of the box into use, didn't have to touch it whatsoever, and we were off to the races. Activating the SpectraView Engine and the ability that it gives you in the out-of-box capabilities that we can really go down into the weeds if you want to. And really the other thing I would keep in mind is there is some, I guess I would call it danger, Dave, of some of these settings, but keep in mind, even if you go into one of these displays and you start setting something and you get over your head, you can revert this back to the factory calibration with just a couple clicks of the button. So it's not like that you can get into this and go too far and suddenly you've got a display that's not usable or that it can't be recovered. So keep that in mind as well. And then finally, just the new products, being able to calibrate them with the wall calibrator software in half the time. And to Dave's point, even when you start that calibrator software and you start making your selections, it's going to give you an estimated time of what it's going to take to calibrate this wall. So in instances where you might be in a tight time window, it's going to tell you this is going to take 15 minutes or this is going to take 30 minutes, so that you know if you want to proceed with that now or if you want to wait until you have an opening at that point that allows for that time. And Dave, I apologize, I just kind of hogged that slide altogether, but anything I missed?
That's perfect. No, I came up with one of my own, I think. And it's something we didn't talk about, but I remember we talked about it with Ben, and we talked about it. It's always been one of those gotchas that anytime hardware needs a software upgrade, right? It's called firmware. And anytime you update firmware, generally the last procedure is to flip the power switch, because you have to completely power the unit down. And as we know, when a video wall is on a wall, you don't have access to those power switches. That can become a problem unless you get them on individual breakers, which sometimes they are, and you get to go find them. But we've actually improved that process now that we can, through our software, be able to upgrade firmware to all displays at the same time, and we've eliminated the need to do full power on-off. So again, that's just another thing that through experience in this, thinking of the things that really all of a sudden, oh no, how do I shut all my monitors off? Do I have to have remote control of my power source? Things like that, remote power capability. Now you actually have the ability within the monitor not even to need to do that. So that's just one of the things I would add in there that we didn't talk about, but I think it's kind of important.
Yeah, absolutely. Can you hit the last slide, Dave?
Sure can. Just gonna click the button.
So just as we wrap up, I know we went a little long, but that was a lot of data that we wanted to make sure that you guys understood. Questions were open for those. Use the Q&A or the chat window for any other questions you may have. From me and Dave both, thank you. Be safe out there. As far as upcoming webinars, we've got a couple that are still on the schedule and upcoming. So NEC Collaboration and Interactive Solutions is actually on the 29th, tomorrow. We've got a Salamander webinar that of how Salamander designs and NEC can work together. That's on June 2nd, and Dave and myself, as well as Salamander Designs, will be on that. And then our final installment of our virtual happy hour will be on June 5th. If any of those events sound of interest, Dave and I's contact information is below. Please reach out to us and we'll make sure that you get the proper invites and the links to be able to join any of those that you wish. And with that, Dave, I'll kick it to you for any closing comments, and then we'll give it back to Gina.
Yeah, I would just add, yeah, they can contact Gina. I think they have her email address on their invites as well. But that's wonderful. Perfect, Adam. Thank you. And thank you, everybody, for attending. I hope this was valuable, and I want everyone to be safe out there and continue looking forward to working with all you. And like I said, we reach out to Adam or I, and then also your local NEC reps, and they'll be in contact with us as well. So I look forward to your next project.
All right, thank you both. Thank you everybody for joining. You know, Adam and Dave kind of stole what I was going to say about some upcoming webinars, but that's great. So I am hosting tomorrow the NEC Collaboration and Interactive Solutions. So if you haven't signed up for that, it'd be great if you can. We can, you can join me on that call. But that is all I have, and we look forward to seeing you on future webinars. And be safe and stay well, everybody. Thank you.
Thanks, everybody. Thanks,
Thank you.
Thanks, Dave.
Thank you, Adam. Thanks, Gina.